Right, we've got to keep an eye on time here, Brian. Enough
Yep.
chatting from me and you, and more chatting from our keynote speaker for this session. Welcome, Or from Permit.io. Let's
Pleasure to be here.
fantastic.
Good to see you again, Or.
I seem to have a cloud over my head in this layout here, but let's add your slides to the stream, and Brian and I will get out the way. And the floor is yours, Or.
Thank you. Hi, everyone. I'm excited to be here. Today, we're going to talk about DARCC. DARCC is a framework, a methodology to work on DevSecOps. A little before we dive in, a little about myself. My name is Or Weis. My background starts in the intelligence core in the IDF. But at core, I'm a developer and a security practitioner. Nowadays, I'm the founder and CEO of Permit.io, a access control solution. We basically enable you to never build permissions again. And I'm also honored to be a Snyk ambassador and try to promote cybersecurity and best practices for developers around the world. Without further ado, let's dive in. So one of the challenges that people are facing today, and it's probably the opening statement for almost any talk you hear today, is the complexity of software. The software stack that we're building is getting bigger. We're adding more parts. We're adding more layers. There are a lot of weak links that are added into the chain, and this just translates to a lot of attack surfaces, essentially attack surfaces all over the plane. And a lot of times when we try to communicate with our team, trying to communicate with vendors that we're working with, trying to communicate with customers we're serving, trying to communicate between dev, ops, and security, it can be very challenging just to wrap our hands around all of these surfaces. And sometimes it can feel like we get lost in the dark. To kind of give an example here so we can understand what I'm talking about, I have an example here of a healthcare startup that does something rather basic for a healthcare startup. It connects with something that they deploy on the hospital side, and then they provide a machine learning driven service with a backend part and a front end application to their customers, which include both patients and doctors that work on that data. They have data scientists working in the background to build a machine learning model, to train it and load it to be used in inference. They have the platform engineers kind of sculpting and planning everything, and obviously R&D building all of the elements here. And just looking at this picture, I think it's already kind of jumping out all the different points where valuable and sensitive data is flowing through the system, where proprietary aspects of the system, like the model here, reside and can be translated into attack services and into vulnerabilities that we have to take care. And just trying to communicate what's going on in this picture and trying to cover all the areas, that's kind of going to take a while, especially if we're going to do this in a way where we are connecting to other partners or vendors or solutions. This is extremely clear when you think about security questionnaires. So anyone who's ever built a product, a SaaS offering, or another one that you cater to a different company, you are probably familiar with these documents, usually long spreadsheets that you need to fill just to communicate the baseline of how you do security, how your product looks, and how it's going to affect the security posture of that customer you're interacting with. Just filling this out can drive someone insane. I know I've filled probably thousands of these by this point, and it can be very stressful, annoying, and also very hard to work with. So that's kind of at the core of the problem that we have. The plane surface itself and the attack surfaces within it are constantly growing. It's hard to communicate. It's hard to work around. It's hard to find where we have gaps and potential weak points that we need to take care. And this is where DARCC comes in. So DARCC is a new methodology, a framework that is focused on being very quick to provide you with a quick top line so you can communicate quickly within your company, between devs and ops, with your customers, maybe instead of security questionnaires with other people, and give you a very quick picture of what's going on, help you find all the points that you need, have coverage for it. enable you to zoom in on different levels so you can have an overall picture, but also apply Dark to more subsets of the problem. And everything very consistent with best practices, and no less important, tools that we can apply to the problem itself. So let's talk about what Dark is comprised from. So first of all, Dark is the 5 layers of basically every application. So no matter what we build, these 5 elements are going to be in existence there, and we need to take care of them. And not taking care of them is immediately translates into potential security vulnerabilities. So the first one, and I think our host here mentioned it at the beginning of the talk here, supply chain. That's a really hot topic now. And so managing dependencies, the dependencies of the software we're building, software we're providing, is a critical thing. So dependency, that's the first layer in Dark. And we basically ask, how do we secure the software supply chain that we're providing? This second part is access control. How do we connect other services? How do we connect other people, other identities to what we're building, and how we do so in a secure way? Is a classic question. We move forward to runtime. How do we know that the software that we've built is going to behave the way that we expect? Configuration. How do we know that we've set and configured the software that we're deploying to run in the way that we expect and want? And lastly, the container. How do we set up the containing environment? How do we make sure that our software is running within the box, within the servers, within the cloud that we intend, and in the way it is intended to work? So those are the layers, and now we're gonna cross them with the best practices. These best practices are really going to be our light in the dark here, something that you can take with you, apply on those layers, and be able to say if you have any gaps in your security. The first one is managing as code. So that's really a classic one and becoming more and more popular. Knowing that we have a very mature ecosystem with how we manage complex things as code for developers. Now we know that we can apply this to basically everything else. We can apply these to policies, to infrastructure, to configuration, to basically all of the layers that I mentioned before. So we want to see that we can apply management as code across that stack. Zero trust. That's also a very common best practice. We need to make sure that what we're building has zero trust and need-to-know basis kind of baked into all of its layers. This will really affect how we compile or how we build the software itself and how we connect different software components between one another. Being event-driven, that's just a necessity of modern applications. If we're moving too slow, if we're not real-time, if we're not responding to changes both in the customer demands or in our infrastructure, we're going to have a bad time. So being event-driven, that's a must nowadays. Decoupling, that's a classic from software development, just making sure that only the parts that need to be bundled together are bundled together, and that we have tools that allow us to separate the different parts that we have. If we don't do so, because of the complexity of software today, we're going to end up with spaghetti code or spaghetti architecture within a very short window of time. Lastly, the two more high-level ones, a unified view. Unified view just means that we are able to monitor the entire layer in a way that is easy, aggregated, and we can connect it to other systems and have it approachable. Here we understand that, first of all, everyone is becoming a developer, and all the stakeholders have to be involved in security. We can no longer apply security as an afterthought. So we need developers to take care of it at day one, but we also need to enable all the other stakeholders: product, security, compliance, even sales and support. We need to enable them to chime in on our security posture, or at least be part of the conversation. Otherwise, we're going to have a bad time just trying to communicate. So these are our best practices, and now we're going to layer them on top of the layers. And so now for each dark layer, we're going to look at each of the best practices, and we're going to ask, how are we implementing the best practice? And even more specifically, how are we applying tools to implement that best practice so we know we actually solve the problem and we're not just talking about it? So I'm going to run quickly through kind of these overview of layers. I'll mention the top tools that I think are worthwhile knowing. And then we'll try to bring this all together back to the example that we've set on the stage for. So dependency, our supply chain. So I'll highlight managing things as code. So SBOM, software bill of materials, is becoming a very commonplace thing. You can find tools for that both in an open source project called SPDX and also within Snyk Cloud. I'll also mention things like Backstage and Port.io, Get Port.io. Starting to manage all the different software components that we have in an approachable way that the developers can manage, share with one another, maintain track of what's going on. That's becoming super important and super critical. And these are tools that are becoming popular to solve that. There are other things here that are maybe worth mentioning. Classic Snyk for your open source dependency. And obviously being event-driven here translates very easily into CI/CD. Access control. So access control has multiple layers by itself. So we have application level access control, infrastructure level access control, and obviously it continues to the network level, physical level, and we need to cover that across the space. Policies code is really solved by great projects like OPA, and now fresh out of the oven, AWS announced a policy language and engine called Cedar. Zero Trust is really managed by the classic concept of doing policy decision points. So instead of having access control baked into our software, we have a separate microservice for authorization, usually called the policy decision point. And we have services like Permit.io and like SpiceDB that we can use to implement that microservice for authorization instead of building it on our own. So those are like a few quick highlights for access control. Moving into runtime, here Snyk code also comes in for our decoupling aspect. I also want to highlight Falco. Falco is a really great project for runtime application security. Really can produce quick alerts. It's also becoming a very popular CNCF project. Gatekeeper with OPA again comes in for policy as code, and Docker is a classic for containerization and basically creating that zero trust element between the different runtime components that we have. Configuration, I'll mention configuration checking tools like ConfTest, the tree, and Checkov. These are also becoming, I think, a very common tool in the arsenal that developers and DevOps use today. Gitops is a methodology to be event-driven around configuration is very commonplace. And we're starting to see configuration management solutions that make it more approachable with things like Configu and, again, Backstage that I mentioned before. Lastly, container. So here, obviously, Docker, Helm charts with Kubernetes and OCI images really shine. Management tools for the overview of it, like Datadog and Prometheus, are very commonplace. And we're starting to see some maturity around making this more approachable with projects like Raft, Velocity, and Env0. So we went through the layers now, and we looked at common tools, or at least examples of common tools that we can bring to the table to try and manage all of the best practices that we need to bring in. And we saw that for each layer, we can look at each of the best practices, and we can apply it in a general fashion. Just in general, how can we go about making sure that we have the right best practices and tools for whatever we're building? Now let's take this back to the specific example that we have here. So we can do two things. One, we can create a quick picture of dark to light up this entire thing, and that's going to be the next slide. But we can also talk about having different points. I can look at, for example, how the data scientists connect to the machine learning model, or how the CI/CD connects to the backend, or how the platform engineers connect to the CI/CD and the backend. For each of those, we can create a dark map. We can apply the framework for each point. So I'm not going to do that for now, but I'm going to do this for the overall picture. And you'll see that we quickly get basically a component that enables fast communication, quick summary, and the ability to kind of zoom in on the parts that we want. And let's just jump into that. So if before we looked at each of the layers separately and we asked in general what we can apply here. Here we're looking at all of the layers together and crossing them in a table with all of the best practices. And we're applying this to the specific case of that healthcare startup that we saw before. By the way, that healthcare startup is a real startup. I didn't mention their name here, but this is based on something that's happening in reality. I know them because they're a customer of mine with Permit.io. So for example, we can see that for the access control part, Permit.io is a solution that they use to solve both decoupling, creating a unified view, and making this approachable for the other stakeholders. And also with Permit.io and Opal, the open source project behind Permit.io, they are able to do this in an event-driven sense. Like many other players, they're using Snyk, both for their supply chain and both for their runtime security. What was interesting in the picture that we saw before, and maybe I'll go back, is that there's both a cloud component and an on-prem component. So in this table, I've kind of broken it down both for on-prem and for the cloud. And that kind of floats up some issues. So for example, in runtime, being event-driven, they're using Falco and a web application firewall to monitor in real time what's going on with their running code. But for the on-prem solution, they don't really have anything. So immediately, just off the bat, looking at the slide, we immediately see where do we have gaps. And in this case, we see that we have a partial gap. We can also see that there are areas that are complete gaps. So for example, they have around configuration, they have a lot of gaps. They're not event-driven. The configurations are deployed once with the basically with the build. So you build it once. If you want, you have to redeploy everything to change configuration. So they're not using anything like feature flags or anything like that. And for the on-prem option, it's completely not event-driven. They have to deploy, they have to send a new image to the customer to have any configuration change on that side. So obviously it's not decoupled, it's bundled into that image, and they have no way of viewing this or making this approachable, not for themselves or their customers. Obviously, what we're covering here is that specific case for that specific customer of mine. Different scenarios that you'll run, your software, the interaction that you have with your vendors or your customers would produce obviously very different slides, very different dark maps. But you'll get these dark maps quickly. It won't take you long. You can probably, if you take your average mid-sized SaaS offering, it will probably take you just a few hours, a day at most, to map everything that you want into a dark map. And then you can use that to communicate internally. You can use that to share it as part of security questionnaires, or maybe in the future instead of security questionnaires. And you can use that to also find gaps in the software that you have or in the solution that you're building. And I think this slide really kind of sums up the way that Dark can really light up our look into our security posture. So kind of summarizing up what we talked about, Dark is relevant for anyone building software, developers, DevOps, SREs, AppSec, and everyone managing the overall picture, architects, security analysts, AppSec, the management team. And it can be a valuable tool to speed up processes on both those sides. For the management, this can really be a guiding principle. When you're starting to build something new, or you're refactoring something, you're working on new architecture, you can start with a dark map to kind of quickly highlight where you have answers for things and where you have gaps that you'll need to address soon. And this can be a way to communicate between organizations. Again, I really think that security questionnaires are a pain in the ass. And even though we have companies like Panarrays making them easier to approach, it's still very cumbersome to work on. So I'm really trying to encourage this. And this can also be a good way to communicate security as part of your docs. So a lot of documentation for SaaS offering today's or products today's include a section on security. Having this as part of that security section would really speed up someone's ramping up into the project and them being able to find the answers for what they need and how they can make sure that the product that they're reviewing is meeting their standards. For developers, this is foremost a checklist. You build something, you want it to be secure, you can go through the checklist through the dark map to make sure that you have an answer for all the different things you're connecting. And this can be also a baseline for a SWOT analysis to understand where your strengths are, where you have gaps, where you need to invest your time when you're dealing with technical debt. And in the end of the day, this can also be a good way to decide which tools you need to invest in. Knowing what you have in place, knowing which gaps you have, prioritizing them, and understanding which ones are more critical can enable you to decide which tools are you bringing on next. Are you upgrading your observability? Are you adding runtime access control? This map can be a baseline for the discussion of what you should tackle first to minimize your technical debt and to basically meet all the best practices that you need to meet. So now I'll pause for questions. I'll say I'm available for questions later. You can find me all across the internet as Or Weis, ORWEIS, on GitHub, on LinkedIn, on Twitter, and you'll be surprised how responsive I am for questions. If you want this deck and you want the framework itself, you can find it at Permit.io blog DARCC. DARCC here is obviously DARCC, and it's available for everyone. And if you're interested in best practices and other concepts that I'm driving, you can also check out this blog on Permit.io for the 5 best practices for building cloud-native permissions. Hope you enjoyed the talk, and I think we have a few minutes left, and I'll be happy to tackle questions if there are any.
All right, thank you so much, Or. And yes, let's put Matt in as well, and let's change the view for a second to this. Oh, I will put the overlay away so we can actually see you, Matt. Like, let's do it like this, and we just put the little logo in. That suits far better. Thank you for this talk, Or. I don't see any questions that were not yet answered in the chat, but I would love if you could share the links that you have on the Discord as well, so people can click on it, because it's very hard to click on slides, obviously, because I think that the whole story about DARCC and how to implement it, I want to get my hands on it and actually try it just to see if it fits. So thank you.
Happy to share those, and I think that's something that I really want to encourage people to do. This thing that I've presented here is really geared towards simplicity and being quick. So you shouldn't thinking, oh, should I adopt a new methodology? Should I adopt a new framework? I think you should put that question aside and just give it a try. I think most people and most other companies that I've used this framework with, you quickly find gaps that you weren't necessarily aware of before. So even if you don't end up implementing this end-to-end or across your stack, this will enable you to figure out things that you might necessarily not be aware of, and that will immediately improve your security posture just by raising awareness.
I had a question that I'd be interested in your thoughts about. I mean, I'm always fascinated by. Actually, we've got a question coming.
Yeah, we got a question coming in from the Hoppen framework. So, Or where does API security come? What are your views about it?
So API security is a component of itself that you definitely want to have. I didn't map all the different components that you have. I mapped the best practices. And API security, you'll have both access control, I think, is a significant part of it. And while you go through the best practices, you'll end up basically implementing API security both in the access control aspect and in the runtime aspect. So the challenge with trying to build a framework around specific components is that it doesn't end. There's always another layer being added. So, and that will make this framework complex instead of simple. So that's not the direction I went with, but I think DARCC definitely touches on it. And anyone building anything with an API, going with DARCC to light it up will definitely touch on API security. It's unavoidable.
Yep, I guess so. So thank you for that. Matt, you had something, so go ahead.
Yeah, I mean, I'm always fascinated to see that folks are still trying to manage things using spreadsheets these days, especially in the era of modern software development where, an application might have hundreds or even thousands in some cases of dependencies, which is just that's like trying to fit a square peg into a round hole, right? I mean, you're just never going to be able to track things like that and look at the risks of them. I still think that the answers for how we do that are still emerging. I know we've got a couple of talks later on today that are around the same space. I mean, I guess the other thing was when we start to look at complex application architectures, and as you pointed out in some of those diagrams, we're often also having requirements on external services, right? That we're using SaaS things within our apps. What are your thoughts on kind of how we quantify risk for that, right? Because do we just say here's a risk boundary, that's somebody else's problem, and that's enough, or
So I think, first of all, maybe to touch on the spreadsheets. So I'm not saying here that you shouldn't have those spreadsheets. It's okay to have them. It's a good tool if you want to do a deep analysis. I think they're really not a good tool if you want to communicate between boundaries, which is kind of the other part of the question that you're alluding to or touching on. So if you're working between vendors or between customers or between different departments, if you're passing around spreadsheets, everyone's going to have a bad time. It's just not something that people can digest fast enough to build a conversation. So you can add those spreadsheets alongside something that will give someone the ability to ramp up quickly and communicate quickly around the sensitive areas. And going to your second point, so DARCC doesn't really touch on prioritization directly. It's more focused around highlighting where you have gaps, and then there's more work to be done around prioritizing them. But I find that especially with security, if you're prioritizing things without a clear unified view, you're basically missing out. Because the weakest link principle might be hiding the actual thing that if you don't take care of, all the other work that you're doing is basically meaningless. So I think should be foremost managing a view, being able to communicate around that, having the discussion of what we have in place, and then being able to prioritize. Maybe in a future update to DARCC, like DARCC 2.0, maybe I'll add something around prioritization, but I haven't tackled that specifically yet.
Great. Well, thank you very much. That's super interesting. Oh, we've got one. Have we got time for? Yeah, we've got time for one more question. I think we've got one. Do we have that on a banner, Brian, or should we just read that one out?
Let me put this on a banner in.
Okay. Well, I'll read it while you're typing. So, how does threat modeling fit in with the framework, and how does threat modeling fit in with permission management?
Ooh, that's a lot in one question. So I think threats, and I kind of touched on it with the SWOT analysis. So the gaps that you have are almost always translating into potential threats and risks that you have. So, and that's also kind of touching, I guess, on your question before. So once you have those gaps in place, you can map them into risks and threats, and then you can prioritize them, and then you can create models of them, and then you can even have simulations around tackling those threats when they happen. It's not something that this framework specializes in, but I think it's a good enabler to do threat modeling. In terms of modeling threats and connecting them to permission management, I'd say that it's around policy, and policy as code specifically. In general, managing policy in complex applications is becoming very, very cumbersome. If you try to keep all of that as know-how and documentation that you have proprietary code for, it will be very hard for you to keep modeling the threats or the friction points that you need to protect with your permission management for the software component you're building. If instead you decouple out your authorization, if you decouple that out and you have your policy managed separately as ideally as policy as code in a unified repository, then it's easy to have a source of truth. And then that source of truth you can model, you can track, you can test, you can do benchmarks on, and you can also have code reviews on it, which is an amazing feat that is impossible any other way. I'd said that in addition, if you use tools like, obviously I'm biased here, but if you use something like Permin.io, you also get low-code interfaces that generate that code for you. So that way you can have the security practitioners work directly on that policy as code, on that source of truth, without having to necessarily be full-blown developers.
Fantastic. Well, I think that's actually a great segue to our next speaker. So we'll leave it there. Thank you again, Or. That was super interesting. And let's drop you out.